Let us discuss question answers in chapter number 5. First in-text questions. Page number 81. Question number 1. Did Doberinus triads also exist in the column of Newland's octaves? Compare and find out. Answer. Yes, we can identify the triad, that is lithium, sodium and potassium. The atomic mass of sodium is approximately equal to the average mass of lithium and potassium. The following sets of elements also followed Doberinus law. HFCl, hydrogen, fluorine, chlorine, beryllium, magnesium, calcium. The atomic mass of the middle element is approximately equal to the average mass of the first and the third element. Question number 2. What were the limitations of Doberinus classification? Answer. He could only classify 3 triads from the elements discovered at that time. Many chemically similar elements like nitrogen, phosphorus and arsenic could not prove the validity of Doberinus theory of triads. Many elements having different chemical properties like carbon, nitrogen and oxygen could not verify his theory of triads. Question number 3. What were the limitations of Newland's law of octaves? First one. All the elements discovered at that time could not be classified into octaves. Second. The law was not applicable to elements after calcium. For example, iron was grouped with oxygen and sulfur, whereas it has properties similar to cobalt and nickel. Newland did not take into account the elements yet to be discovered. The newly discovered elements could not fit into his table. More than one element was given the same position in order to accommodate all the elements, although their properties did not match with other elements. For example, cobalt and nickel were grouped with fluorine, chlorine and bromine, although they had different properties. It did not work with heavy elements. It could work only with lighter elements. Page number 85, question number 1. Use Mendeleev's periodic table to predict the formulae for the oxides of the following elements: K, C, Al, Si, Ba. Answer. K2O, CO2, Al2O3, SiO2 and BaO. Question number 2. Besides gallium, which other elements have since been discovered that were left by Mendeleev in his periodic table? Any two. Answer. Scandium and germanium. Question number 3. What were the criteria used by Mendeleev in creating his periodic table? Answer. Mendeleev created his periodic table on the basis of atomic mass, which is fundamental property of an element. He also considered the similarity of chemical properties in elements. Among the chemical properties, he mainly studied compounds like oxides and hydrates of elements, since both oxygen and hydrogen are reactive and easily form oxides and hydrates. Question number 4. Why do you think the noble gases are placed in a separate group? Answer. Noble gases are inert. They are unreactive, that is, they do not react with other elements. Hence, they are placed in a separate group. Page number 90, question number 1. How could the modern periodic table remove various anomalies of Mendeleev's periodic table? Answer. The modern periodic table gives a logical explanation of assigning the first group and the first period position to hydrogen in the periodic table. It assigns a position to the isotopes of elements. It gives a logical explanation of assigning elements of higher atomic masses prior position in the periodic table. For example, Ar and K CO and Ni, etc. It has distinct position for metal, non-metal and metalloid. It gives logical explanation of the similarity and differences in the properties of different elements. Question number 2. Name 2 elements you would expect to show chemical reactions similar to magnesium. What is the basis for your choice? Answer: beryllium and calcium would show chemical reactions similar to magnesium because they have the same number of valence electrons. Name A. 3 elements that have a single electron in their outermost shells. B. 2 elements that have 2 electrons in their outermost shells. C. 3 elements with filled outermost shells. Answer: A. Lithium, sodium and potassium have a single electron in their outermost shells. B. Magnesium and calcium have 2 electrons in their outermost shells. Helium, neon and argon have filled outermost shells. Question number 4. A. Lithium, sodium, potassium are all metals that react with water to liberate hydrogen gas. Is there any similarity in the atoms of these elements? B. Helium is an unreactive gas and neon is a gas of extremely low reactivity. What, if anything, do their atoms have in common? Answer: lithium, sodium, potassium have the same number of electrons, that is 1 in their outermost shell. B. Helium and neon have completed outermost shells. 2 electrons in the case of helium and 8 electrons in case of neon. Question number 5. In the modern periodic table, which are the metals among the first 10 elements? Lithium and beryllium are the metals among first 10 elements in the modern periodic table. Question number 6. By considering their position in the periodic table, which one of the following elements would you expect to have maximum metallic characteristics? Ga, Ge, As, Ac, Be, gallium, germanium, arsenic, selenium and beryllium. Answer: the metallic character decreases across a period from left to right. Be, beryllium has the maximum metallic characteristics since it present on the left hand side of the periodic table. All the other elements are present on the right side of the periodic table. Page number 90, question answers. Question number 1. Which of the following statements is not a correct statement about the trends when going from left to right across the periods of periodic table? A. The elements become less metallic in nature. B. The number of valence electrons increases. C. The atoms lose their electrons more easily. D. The oxides become more acidic. Answer: C. The elements do not lose their electrons easily due to decrease in atomic size. Therefore, C is not a correct statement. Question number 2. Element X forms a chloride with the formula XCl2, which is a solid with a high melting point. X would most likely be in the same group of the periodic table as A, Na, B, Mg, C, Al, D, Si. Answer: B, Mg, because the valency of X is 2 like that of Mg. It belongs to group 2. The compound XCl2 is ionic solid with high melting point. Question number 3. Which element has A. 2 shells, both of which are completely filled with electrons? B. The electronic configuration 2, 8, 2. C. A total of 3 shells with 4 electrons in its valence shell. D. A total of 2 shells with 3 electrons in its valence shell. E. twice as many electrons in its second shell as in its first shell. Answer A. Neon 2,8. B. Magnesium Mg has electronic configuration 2,8,2. C. Silicon Si 2,8,4. D. Boron B 2,3. E. Carbon C 2,4. Question number 4. What property do all elements in the same column of the periodic table as boron have in common? B. What property do all elements in the same column of the periodic table as fluorine have in common? Answer A. All elements have valency equal to 3 because they all have 3 valence electrons. B. All elements are nonmetals. They can gain 1 electron easily to form negative ions, which have stable electronic configuration as that of nearest noble gas. Question number 5. An atom has electronic configuration 2,8,7. A. What is the atomic number of this element? B. To which of the following elements would it be chemically similar? N 7 atomic number, F 9, P 15, AR 18. Answer A. Atomic number of the element is 17. B. F 9 will be chemically similar to the given element. Question number 6. The position of 3 elements A, B and C in the periodic table are shown below. Group 16, 4th period, and in the group 17, A is present in the second period and the C is in the 4th period. A. State whether A is a metal or a non-metal. B. State whether C is more reactive or less reactive than A. C. Will C be larger or smaller in size than B? D. Which type of ion, cation or anion will be formed by element A? Answer A. A is a non-metal. B. C is less reactive than A. C. C is smaller in size than B. D. Anion will be formed by element A because it is a non-metal and can gain an electron to form negative ion which is stable like a noble gas. Question number 7. Nitrogen atomic number 7 and phosphorus atomic number 15 belong to group 15 of the periodic table. Write the electronic configuration of these 2 elements. Which of these will be more electronegative? Why? Answer nitrogen atomic number 7, so electronic configuration 2,5. Phosphorus 15, so electronic configuration 2,8,5. 15 is the atomic number. N is more electronegative than P because it is smaller in size than P. Therefore, it can attract shared pair of electrons towards itself to more extent due to greater effective nuclear charge. Question number 8. How does the electronic configuration of an atom relate to its position in the modern periodic table? Answer. The position of an element depends upon the number of its valence electrons which depend upon its electronic configuration. Those elements which have same valence electrons occupy same group. For example, the elements having 1 valence electron belong to group 1 and the elements having 2 valence electrons belong to group 2. Period number is equal to the number of shells. Example, if element X has the atomic number 11, its electronic configuration is 2,8,1. It has one valence electron and belongs to group 1. And it has 3 shells, therefore it is in the third period. Question number 9. In the modern periodic table, calcium atomic number 20 is surrounded by elements with atomic number 12, 19, 21 and 38. Which of these have physical and chemical properties resembling calcium? Answer, Mg12 and Sr38 will resemble with Ca20 because they have same number of valence electrons and therefore they have same valency. K, L, M, N and O. Mg atomic number 12, so 2, 8, 2. K atomic number 19, so 2, 8, 8 and 1 in K, L, M and N shells. Ca atomic number 20, so 2, 8, 8 and 2. Sc 21, so 2, 8, 8, 3. Sr 38 atomic number, so 2, 8, 18, 8 and 2. Sc is scandium. Sr strontium. Next question number 10. Compare and contrast the arrangement of elements in Mendeleev's periodic table and modern periodic table. Answer, in Mendeleev's periodic table, elements are arranged in order of increasing atomic masses. But in modern periodic table, elements are arranged according to increasing atomic numbers. In modern periodic table, there are 18 groups and 7 periods, whereas in Mendeleev's periodic table, there are 8 groups and 6 periods. Transition metals were placed along with representative elements in Mendeleev's periodic table. In modern periodic table, the transition metals are in the center of periodic table, whereas representative elements are at left and right of periodic table. Lanthanides and actinides are at the bottom in the modern periodic table, whereas in Mendeleev's periodic table they were not present. In modern periodic table, noble gases occupy group 18 in the beginning. In Mendeleev's periodic table, noble gases were not present. Group 1 and 2 elements have same position in both tables. Hydrogen also occupies same position in both.